and rose to the rank of Rear Admiral. In his career, it included duties as commander of the Naval Meteorology and Oceanography Command, oceanographist, and navigator of the Navy, and Deputy Assistant Chief of Naval Operations for Information Dominance. While serving in the Pentagon, Dr. Titley initiated and led the U.S. Navy's Task Force on Climate Change. After retiring from the Navy, he served as Deputy Undersecretary of Commerce for Operations, the Chief Operating Officer position in the National Oceanic and Atmospheric Administration. His topic is Climate Change Erodes National Security. It couldn't be more timely after the last week we've just all experienced, at least on our TVs, and many of us might have done personally. With that, Dr. Titley, I'll turn it over to you.
Thanks very much, Lynn. Can you guys hear me in the back, everybody? Okay, great. Wonderful. Well, thanks so much. I really appreciated also being part of the business meeting. I didn't blink, so I saw it. I was actually asked to speak to Warren Buffett about 2 months ago at his annual business meeting. Yours is shorter. Yours is shorter. I can tell you that. So if you see Warren, let him know yours is better. It's a lot faster here. Okay. What we'll talk about here in the next 35 to 40 minutes or so is really just kind of a very brief overview on climate and climate science. I'm not going to go a whole lot down there. Happy to talk about any kind of questions that anybody has in the Q&A. But there are people who have studied their entire lives on the climate science. That is not me. I'm a recovering weather forecaster. I forecast for ships and aircraft and things like that, and keeping like typhoons and hurricanes away from aircraft carriers and that kind of stuff. But I've been involved in climate now for maybe a decade or so. Okay, so we'll just kind of go through what we have up here. And really, as I said, my background is really one of a meteorologist. This was my prized possession when I was 10 years old. It's a rain gauge. It's a manual rain gauge, and I bugged my parents, and eventually that was my birthday present. I was very, very happy about that. So I was one of these people who just always knew what they were going to do from about first grade on. I knew I was going to do something with weather. Had no idea it was going to be climate or even the Navy, but I knew I grew up in New York State, and I figured out fairly early on that yes, I was going to do weather. Penn State is close, of course, to New York, and it was the largest, best well-known program anywhere close to me. So although that is not me on the lower right, it could have been, because everything, of course, was manual back then. I know some of the younger people here probably don't believe there was a time like that, but there was. And my parents said, hey, congratulations, you're in Penn State, now go figure out how to pay for it. So, you know, Penn State is many things, but cheap tuition is not one of the things you associate with them, either now or back then, especially if you're out of state. So this was post-Vietnam. And the Navy was desperate enough, they took me as for Reserve Officer Training Corps. I thought this is a good deal. They pay for college, I do 4 years, I'll get out, I'll go work for AccuWeather or something like that. But a funny thing kind of happened. It turns out that I enjoyed being in the Navy and driving ships, big ships, little ships, everything kind of in between. And the Navy thought I was at least minimally competent, so I was able to hang around there for about 32 years or so. I then worked for a little while at NOAA. So the head of the Weather Service and the Ocean Service and the Satellite Service, they all worked for me for a little bit, and that was interesting. And then I ended up at, at Penn State. And really that's just kind of a one-slide version. That's a fairly recent picture of our faculty. And I think the only reason that I'm on the faculty is that everybody who was a professor when I was there is now retired, because I don't think they would actually be too happy that I'm but anyway, I am, and it's a whole lot of fun. Okay, I sometimes go through this slide, but since this is the World Affairs Council, and I love, this is maybe the 4th or 5th chapter across the nation of the World Affairs Council that I've had the honor and privilege of talking to. I know that many people here, your interests are far beyond just climate. It's much broader in international relations and kind of understanding our place in the world. Now, sometimes when I talk to all of my climate friends, they're really more-sighted on climate, and I understand why. But I think it's important to sort of place this issue in perspective here. So when you sort of think about the world of the 21st century, one of the things that will probably be an enduring competition and an enduring requirement is really how do we all get food, water, energy. Rich countries, poor countries, everybody in between, northern hemisphere, tropics, southern hemisphere, that's always an issue. So the ability to get food, energy, water, and of those three, I would argue water may be the very most important of those, because with water, you can kind of get the other two. So that's an issue. Whether it's good or bad, right or wrong, I'm not going to get into today, but the fact is we're basically in a globalized world. And there are certainly many benefits. If we go to Walmart, we can get lots of cheap stuff that was made halfway around the world. One of the challenges with a globalized world now is that things or events, whether they're natural or man-made, that happen quite literally half a world away from us, can come and impact us. So a few years ago, some people here may know that there was some very serious flooding in Thailand. That came within a few days of basically shutting down supply chains for both autos and American jobs, as well as a lot of the stuff that we all get from Apple nowadays. That came very close in some of the portable disk drives. That then impacts Silicon Valley, it impacts US jobs. So things that happen seemingly 12 time zones away from here can really come back and impact us. Technology marches on. My students probably think that I still have this phone. I don't. I gave it up 3 weeks ago. So I don't have that one anymore. And we could do a whole afternoon, a whole series, a seminar on technology implications on so many aspects of the world. One of the things it does sort of with respect to climate and climate policies is it forces transparency, whether we like it or not. I would argue that in many cases our government has not liked it. Think Snowden, think the National Security Administration. So, but also with that transparency, when people think about it, it makes it really even harder to do all these big conspiracies that we hear about. I actually wrote an article on how the National Hurricane Center, even if they wanted to, and they don't want to, but even if they wanted to somehow secretly come up with a forecast to make something seem worse than it was, if you watch Twitter, there's 1 million people following their every move and every model. So one of the many things that technology does is it drives transparency. It drives transparency in the data, in the science. It also drives transparency in the policies and who is and who is not doing what. And then, of course, there's population. So as we were really coming out of the last ice age, we've had this period of climate stability, and we had slow increases of population, and then, of course, with advances in not only food, but also, of course, medicine and many things, that we now have a population order 7 billion or so, and still increasing. And I'm not here to say that's too many people, or we can't do this, or gloom and doom, or things like that. But now as we start changing the climate and pushing it into a new and different state where we have not as human civilization, yes, the climate's changed many times before, but not when we've had this number of people and this kind of civilization. That is going to be a pretty big stressing function, because we're not just trying to take care of 1 million or 2 or 3 million people. We're trying to take care of order 7 billion people, probably going to 9, maybe 10. And we're going to do that in climate that is changing, and changing in ways that we as humans, as human civilization, have not experienced. Okay, and finally we do this, that's the G20 Economic Council, we do this and we tell ourselves we're all out of money. So are we or are we not? I'm not going to get into that, but our self-talk is that we're out of money. So population, technology, resource competition, technology moves along, we're going to do this in a changing climate, and we tell ourselves we have no money. Apart from that, Should be pretty simple, right? So, but the reason I walk through this, spend a couple minutes on this, is when we talk about climate, and I'm going to talk about climate and its impacts for the rest of this talk here, you know, a number of these other issues both impact climate and are affected by climate. It's sort of a two-way interaction, sometimes non-linear. So it's just good to kind of remember that in the back of our heads here. So very simply, why should we care? And I really talk about three things. I find people can remember three things. So I can remember three. Just as a side note, the Navy about a decade ago, we had this exquisite maritime strategy. It was wonderful. Came out of the War College. I mean, tested the brightest minds, put it together. They had like 7 things. So just when I was an active duty admiral, it's too bad Admiral Cooper's not here, I'd ask him this. You know, I would just go up to my fellow admirals, right, the leaders of the Navy, and says, hey, quick, tell me those 7 things. 3, we can remember 3 things. People, water, change. That's really what climate comes down to. This is about us. It's about you and me and our neighbors and our families. It's about our towns, it's about our cities, it's about like Pennsylvania, eastern Pennsylvania. It's not necessarily about the polar bears. The environmental organizations, you know, very well-meaning, very deeply caring people, but it's not like somebody sat around in some unsmoke-filled room and said, you know, my God, what's going to be our icon for climate change? But it kind of became, you know, that picture of the polar bear, right? You know, if I said climate, shut your eyes, climate change, what's the first picture you see? Most of us would see that scrawny polar bear on that little piece of ice in that big blue ocean, right? I mean, that's what we see. But, you know, okay, that's an interesting visual, but is it emotional, personal, or relevant? Because those are kind of the things, if you're looking for a message that actually makes sense, that connects with people, it's sort of emotional, personal, and relevant. Some people, polar bears are emotional, charismatic megafauna. Probably not personal to too many, unless you've been up on Svalbard and being chased by one, or relevant. So I talk about the people because we're the ones who get impacted, whether you look at people in Harvey, whether you look at people down in the Caribbean right now, or even all the flooding on the east coast of Florida when the storm went up the west coast. That doesn't usually happen. So it's really a people issue. It's about water, and I kind of mentioned the water on that previous slide there, but I sometimes tell people it's really all about the water. I mean, the water is the business end of what we need to survive and for food, for our own life. What the climate is doing is we're getting too much, too little water, wrong place at the wrong time. Sometimes now salty where it used to be fresh. The land is wet where it used to be dry. The water is liquid where it used to be frozen as the ice melts out. And even the chemistry of itself of the oceans are changing. So this big blue dot here, that's all the water in the world, all the oceans, kind of to scale. If it was in a cube, kind of stick it over Denver. That blue dot over Nashville is all the fresh water, including most of which we can't actually access. And if you look carefully, it's not a speck on the screen, but there's a little tiny dot over Atlanta. That's the usable or the accessible fresh water. But how that water changes and how that water cycle changes is kind of the business end, if you will, of climate change in many aspects. You can find other integrating principles, I'm sure. But to me, you know, climate can be just so overwhelming. There's so many aspects. It sounds, oh my God, how do I think about this? How that water is changing is a pretty good way to integrate that. That gets everything from more or less rain. It gets the polar ice caps, the sea ice melting out of the Arctic. It gets some of these glaciers we've heard about in the last few weeks, few months. In the Antarctic, it kind of captures all of this here. Okay, I'm just going to do very, very basic science. This is my cartoon version of science, but that's okay. When people talk, whether it's climate scientists or physical scientists, really science in almost any field talks about, you know, how much do we understand something? There's usually, I think of it as like 3 legs of a stool. You know, there's first, do we understand the theory? Do we understand the why? You know, sort of trace it back to, you know, F equals ma or E equals mc squared, you know, guys like Einstein and Newton. And we sort of trace it all the way back to those very fundamental theorems that we've known now for centuries. So do we understand what's going on? And we either do or we don't. What does the real world say about this? And it's not just one data set, but do I have different types of data sets, independent observations, we would call it in the science community, that all lead to the same conclusion? Or does data set A say, hey, you're over here, and data set B say you're here, and data set C say you're here? That tells me we probably don't know what's going on, or there's no strong signal. But if there are these multiple data sets that are all pointing in the same direction, then that kind of leads to understanding. And then finally, can we predict it? Certainly in some of the physical sciences, like meteorology, like climatology, ultimately, can you predict this? And if you can, that's pretty good. So we look at the forecast for Irma. Were they perfect? No. But they were pretty darn good. The fact that we can tell you where a strong hurricane, one, it's going to be really strong, and two, 5 days out, we can tell you to within 100 miles of where that's going to be. I mean, even if you had told me when I was an undergrad at Penn State in the 70s we could do that, I think either that was fantastic or you're on drugs, one or the other. So we can do these things. And I'll just step through very quickly where we are with some of these things on climate. And as I said, this leads to understanding. Okay, there is not a test, don't worry. But when I was talking in the Pentagon, when I started the Navy's Task Force on Climate Change about 8 or 9 years now ago, I had some of my fellow generals and admirals ask me, it's like, Titley, my God, did you get religion on this? And I said, no, I just went to the Church of the Radiative Transfer Equation. Because it turns out that the basic physics, the basic understanding of this is what I call cutting-edge 19th century science. We had, these guys here, Fourier, Frenchman, Tyndall, Lescott, and then Arnhus, a Swede, actually figure out the basic theory of greenhouse gases, really of climate change, really starting in, I think, about 1824. Tyndall made some improvements on what Fourier came up with, and by the time you get to this guy Arnhus, a Swede, he was actually doing calculations, with pencil and paper. He actually underestimated, because he underestimated how much greenhouse gases the Industrial Revolution was putting out, but he was certainly on the right idea. So you had a Frenchman, a Scot, a Swede. They did not go to a bar, as far as I know, but it would have been an interesting conversation. So we have actually known this theory. It's not quite 200 years, but it's about 160, 170 years. So, and nobody's really been able to overturn that theory. Thousands of scientists have sort of taken a look at this. So anybody here in the science field? So we have a couple, maybe a couple. So you probably know, I mean, how do you get your name known forever and they name universities and buildings and institutes after you? It's by coming up with a theory that nobody's ever come up with before. So all the institutional incentives for the science community are to disprove these guys, because then they'll have the University of Titley in the year 2500. Trust me, that's not going to happen. Or the University of somebody, or somebody's institute. So lots of people have frankly tried to poke holes in this, and what that does is it basically, you figure out the rough edges and you make it stronger, and that's kind of how science advances. It's not like we have this, we're going to get to this holy grail goal. It's more kind of like this. You sometimes go down dead ends, but over time, through peer review and a lot of people frankly competing with each other and then sharing the results, you find out what's going on. So this has withstood the test of time for about, maybe 150, 160 years or so. Okay, if you're under 25 in here, do you know what this is? I know some other people do. Yeah, it's a sextant. It's a sextant. Why do I have that? And I mentioned, so I was in the Navy, and probably one of my very most fun jobs, I don't tell the people like when I was later on and I was supposed to have the fun jobs, but one of my most fun jobs is like my second job when I was navigator on an old guided missile destroyer. This was in the era before GPS. There were none of these things. You did not just pull something out of your pocket and find out where you were on the world to within 2 meters. But you actually had to go shoot the stars and you know, kind of navigate like Columbus did. Except we did have time, so it made it a little bit easier on that way. But you could find your way around. But what you learned is being navigator is you look at all sources of data, but you don't trust any one source 100%. And that's, I think, a way to, in general, really look at scientific observations in general, or climate observations in specific. So again, it's not that if you just had one data set, does that tell you something, but you have different ones, and we call them independent. They have nothing to do with each other, but they all point to the same direction. When I could shoot 3, 4, 5 stars, and they all kind of told me, yes, you're right here, that made me feel pretty good. Okay, so this is just one data set from NASA, and you may have, I don't know if you've seen this one or not. So let me, before I start it, I'll just tell you what you're going to see here. If it's blue, in general, it's colder than the 20th century average, so 1900 to 1999. If it's yellows or reds or oranges, it's warmer than the 20th century average. It's average for the whole year, so this isn't weeks or days. It's the average temperature of the day plus night divided by 2, and average sort of throughout that 12 months. So these are pretty big, broad averages, right? And then we're just going to look at about, you know, 130 years of them. If you want to know the date, it's right here, and that date's going to change. So everybody got it? That's what I'm going to show. So we'll run this maybe a couple times here. I think we got time for that. Okay. So here we go, late 19th century. Again, mostly cooler than the 20th century. There's 1900. But you can see, you know, sort of these blobs come up and down, and that's sort of the internal, the natural variability of the climate system, of the Earth system. Watch the Dust Bowl here. Here we go in the 30s. So you can see in the US and parts of Europe, pretty warm, but not everywhere, but certainly in the US. Here's the 50s, 60s coming up right here. So there's the 70s now. Here's the 80s. 88, okay, 1990s.
Oh my God.
98, 2000s. And this goes to 2012. If I had 13, 14, 15, and 16, it would actually be warmer because we now set even warmer records than that, but that would require me being more good with YouTube and PowerPoint than I am, so I use this. But that kind of shows it. I'll just run it one more time, and you know, it's kind of fun to, you know, maybe look at, you know, where did your grandparents come from? Maybe it was Europe, maybe it was South America, maybe it was Africa. So you can kind of see, you know, either pick a place and kind of see these ups and downs, or just sort of watch the broad thing. You can sort of use this a lot of different ways. Again, here comes the Dust Bowl. So really warm in parts of the US through the 30s. Here's World War II, okay, post-World War II into the 50s, 60s. These are really spectacular in Antarctica. Honestly, I wouldn't pay too much attention because there's just not that many observations down there. And then of course we've got this kind of distortion and projection. But all the middle stuff is pretty good. So 98, 2000, made it through Y2K. And 2012. So that's, again, these are just, you know, and if you don't like the NASA observations, you can look at NOAA. If you don't like NOAA, you could look at the Japanese or the Brits. You get the same answer. If you don't like any of those, if you think the governments are all in on this, there was actually a Berkeley data set out by a guy who didn't believe any of these data sets, and what did he get? Same thing. So that's pretty much what the temperatures are showing. There's a whole ton of other stuff we could look at here. We could look at, in Norfolk, I'll just talk about this one here. So this is this lower left graph here in Norfolk. This is hours per year on the left, and this is years starting in 1920. Apologize, it's probably a little hard to see. But I think you can kind of see, this is actually, the Hague is not the Hague, Netherlands, it's just a neighborhood in Norfolk, Virginia. But this is the number of hours that neighborhood is actually underwater, like underwater from the Chesapeake. And you can see these spikes. What do you think those spikes are? Hurricanes, yeah, hurricanes, or even big nor'easter storms. That's exactly what they are. But I would argue, there's kind of a trend there. So there's a trend. Arctic ice coming down. I'll talk about that in a later pace. This is just another way to look at temperatures just every decade and how they've been coming up. And I'll show this if we have time. I think that's the next slide, actually. That right? Okay, it's not the next slide. Sometimes though, but I will talk about on the, this was from the winter time. This was February 11th. Sometimes you don't have to have a PhD in climate scientist. We don't all need to be Mike Mann to figure this stuff out. This is the temperatures in Oklahoma this past February, 4 o'clock on the 11th of February, and when you have 99, 98, 97 in February in Oklahoma, that kind of tells you maybe something's going on because it's not supposed to be near 100 in Oklahoma in February, but it was. So those are the kinds of things that we see. Yeah, here we go. This is this comes out of Munich Re, one of the big reinsurance companies. And really what they are doing is just counting the number of weather and climate related, what they would call hazards. If anybody here works in the insurance or reinsurance industry, that's a few people probably are here. So you have hazards and you have vulnerabilities and you have exposures. This is just the hazard, what's happening here. And don't worry about the orange versus blue versus green, but those are sort of combined. Those are the weather and climate numbers. And you can see certainly year-to-year trends, but I would argue that's an overall increase. Something that actually gives me some confidence in this data set is if you can see the red ones down here at the bottom. Anybody want to, just kind of with your eyeball, this is not a real test here, but just kind of with your eyeball, what's the trend on those red bars at the very bottom? I'd argue it's flat. Yeah, I'd argue there is no trend. So those are things like earthquakes and tsunamis and volcanoes. And the fact that it's flat tells me that Munich Re is in fact probably counting honestly, so they're not conflating this with either greater wealth, because of course, as a world we're getting wealthier, or more number of people. We saw what the population's doing. So they're probably, just counting. And the fact that these weather and climate events are going up, but the volcanoes and earthquakes are not, tells me, yeah, the weather and climate events are probably going up. We could spend all afternoon, actually we could spend the rest of the week going through various different types of evidence. I'm happy to talk more about this in Q&A, but I hope I've been able to show some of you that there's a lot of different types of evidence that combined with 170 years of theory leads the climate people to why we have the understanding. Since Harvey and Irma have been so much in the news, we can talk about attribution, but I prefer to save it for the question and answer side. Last year I chaired a National Academy of Science Committee on the attribution of extreme weather events, and so I'm happy to talk about that, but I'm probably going to save that for Q&A there if anybody's interested. The third leg of my stool was what? Prediction. And so let's see how we've done. And actually on this top one here, these are predictions that were written in a main science magazine called, not surprisingly, Science. That's what it's called. I don't make this stuff up. And the black lines is some guy named Jim Hansen, not the Muppets guy, but the climate guy. He published this. You can go, it's the May 1980 issue. And you can actually see how the black line, that's what he was publishing. And then some smart person said, hey, 30, 35 years later, let's see how that guy Hansen actually did. And that's what that big, thick magenta line is. That's the changes in the temperature there. So was he right? No, he wasn't exactly right. He was actually a little conservative. He was a little too cool. But I would argue that he certainly had the right idea in that prediction or projection, we would call it, actually showed us going up. Same thing here with the IPCC, basically the big international or UN consortium of all the forecasts. They're done about every 5 or 6 years. These are the ones from the year 2000. And why do I show that? It's like, well, we now have, what, a 17-year track record on those. So how did they do? It turns out that the black line is the average of all the climate models that went into this. And then these colored lines are, again, those annual temperatures. And you can see that the black lines, they're The climate models do not capture the year-to-year up and downs. What they do capture is the average trend. And that's sometimes important to know. So don't look for a climate model if you want to know what next year is going to be. Do look at a climate model if you're interested in the next 10, 20, 30 years. Okay, so that's kind of what we've seen. And it's not just the government. It turns out that our friends at Exxon, December of 1980, same time that that Hansen guy was putting his stuff out, Exxon actually, I kind of got this, they didn't exactly give it to me, but they came up with the same answer. Why? Because, I don't know, has anyone worked for the oil, or used to, or either does work for the major oil companies? They're really smart people. They hire really, really smart people, including really smart scientists and smart engineers. It's not too surprising, given 170 years of theory, that they would come up with the same answers. Okay, so here's where I ask, who now believes in climate change? And I don't mean just believe, but I mean who believes in climate change? So show of hands. Oh, I'm sorry, I do not. I do not. I know, this is a trick question, and the reason it's a trick question is science is actually not a belief system. Okay, it's not a belief system. I'm convinced by the evidence. But belief systems are maybe things that we would do maybe on a Friday night or a Saturday night or a Sunday morning. Those are belief systems. We have a lot of belief systems, and we need belief systems. But the science kind of works on evidence, and does the evidence convince you that these theories are basically correct or not? So I'm convinced, but man, if I had a dime for every time I was asked if I believed in climate change, I could retire now. So, okay, I'm sorry, but it is sort of worth remembering that it's a climate change. So let me just talk about climate as a security risk. And I really hate bullet slides, but I've got three bullets here. And again, because I can only remember three things. But really, if you want to now step down from climate writ large into why does a security enterprise, why would the Department of Defense, why would the Navy, why would the Air Force care about this? These are really the three things. We change the operating environment. So when we send our soldiers, sailors, airmen, and Marines forward to go do the nation's business, if we have not prepared them for the right environment, we are not helping them succeed. And the American way of war is we don't want to fight here. We want to fight over there, wherever over there is, but that's what we do. But we want a home field advantage. Why? Because we want to win. We are not interested in a fair fight. We want every advantage for the U.S. Part of that advantage means understanding today's and tomorrow's physical environment, or if I was talking inside the Pentagon right now, I wouldn't call it that. I would call it the battle space, the physical battle space. But the weather and the terrain and the climate are part of that. So if that's changing, we would want to account for that, just like the Department of Defense accounts for changes in demographics and populations and political situations. Why wouldn't you account for changes in the battle space? So of course you do, because why? We want to win. How will climate impact our own security infrastructure? And we have seen, really with Irma, just last week, hurricane comes up the west coast, actually inland of Florida. It weakens to what? Just a Cat 1, even a tropical storm. And we're seeing record flooding in Jacksonville. Jacksonville has two very big naval stations. It has a naval air station down to St. John's, and it has Mayport, which is where I used to be stationed actually, right on the mouth of the St. John's. That stuff's all underwater from a not really that catastrophic storm. It was catastrophic for the Caribbean, but imagine had we put a Cat 5, Cat 4, Cat 5 up into there, we wouldn't, Jacksonville would be absolutely devastated. So we're seeing, even with relatively weaker storms, bigger and bigger impacts. And then finally making bad situations worse. And I'll talk a little bit about Syria in that regard there. This really just, excuse me, is another way of looking at this. So capacity, readiness. Readiness means not only do you have soldiers, sailors, airmen, and Marines, and you have all the gear, the equipment, can they actually do the job? And then new missions is just that. So we see disaster relief. We know we can do the job. The military is very good at that. But if we keep having more of these, then do you have enough to do this? Or do you in fact need to start thinking about separate forces that do nothing about then humanitarian assistance and disaster relief? So that's kind of how to read this. This is actually a slide I gave to 70 heads of navies, basically everybody that talks with the US Navy. And that's why it's kind of boring because mostly flag officers like kind of boring slides. And two, it's really written sort of in more defense terms than in science terms. And I think we all know that, right? If you're talking to somebody, talk in their language, not in your language. It can help out. Okay, let me just show the Arctic, and then I'm going to go through here fairly quickly. This is, again, another animation. This one is not from NASA. It's from my former colleagues at NOAA. And I'll just show you what we're looking at. So just for orientation, imagine you have this God's eye view of the Arctic and the North Pole. The North Pole would be right about here. So Greenland's at the 4 o'clock position, Alaska at 8 o'clock. Russia goes from about 9 to 1, and then Scandinavia over on the top right. So what we've done is we've taken the civilian satellites, and these are really cool. They're not just visible, but they're actually radar. They're microwave images, which is good because it's dark up there a lot and it's cloudy up there a lot. So one, we get nice coverage. The other thing that's even cooler is you get different kinds of return of signal, whether it's old, hard, thick ice versus the relatively newer ice. So the relatively newer ice is the deep blues, and the old, hard, thick ice is the white. So we'll just run this, and again, here's the time. So there's 2012, and I'll just run it one more time. So one you can see, and if you're a weather or ocean geek like me, this is really cool. You can see the structure and the dynamics and the ice flowing past Greenland, which it does every year. But watch as we go 2002. Watch when we get to 2007. So here's 04. It seems to be coming down a little, maybe not a whole lot. Here's 07. Boom. Where'd the ice go? Tries to come back, like my stock market portfolio tried. And then 2012, even less. And if I, again, because I'm not the most technologically literate person, if I updated this, you would see us bouncing around or just above those 2012 levels for the last few years. So this really is the most rapid change, I would argue, on the face of the Earth with climate at this point in time. So we've gone from an ocean that had 30 to 40% of this very, very hard, thick, multi-year ice, we call it, down to maybe 10% if you're lucky. So what we're seeing is a tremendous potential for opening up the Arctic to all kinds of human activity. And that means that this will at some point become a security issue. So we're going to see transit here. Let me go on to the next slide here. So just, there's a whole potpourri of issues. But if you go up, has anybody been up in the Arctic, worked up there? So a couple people have, yeah. A lot of infrastructure, Walmart's in every corner, not so much, yeah, not so much. Very, very austere environment. Even though it's changing and it's warming faster than any place on Earth, still an incredibly austere environment. There just ain't nothing up there. It turns out that if you are trying to drive ships across it, the charting, maybe 10% at best of the Arctic is charted to modern standards. As I said, very little up there. And sort of the paradox is, yes, it's warming, but the operating environment is still very, very challenging. And in some ways, maybe even more so, because as you melt that ice out and you have winds and storms, you can actually build bigger waves now than we would have seen maybe 10 years ago or 20 years ago. Lots of security concerns. When I go talk to the Japanese say, hey, if you guys go to the Arctic, who will be in the Pacific? It's like, well, that's kind of a good question, isn't it? Do we have enough space? If you're Russia, this is what Russia looks like if you were standing on the North Pole in an ice-free Arctic. So they're spending a lot of money sort of revitalizing their northern sea route. They're putting in bases. They have 40 icebreakers, all this sort of thing. But, it's actually pretty rational. The Russians look at the Arctic coast as we do the Gulf of Mexico. And they're trying to exploit it and develop it. So I don't get too worried about what the Russians are doing off their coast, any more so than hopefully they get worried about what we do in the Gulf of Mexico there. Happy to talk more about this later on. Here are the trade routes that will be coming up. The Northwest Passage, this is the one everybody hears about. Probably not going to be a whole ton of of traffic through here. It's shallow, it's hard to drive ships through here. So it's opening up, but it's not going to be a lot. The red line is the line the Russians are pushing. It's called the Northern Sea Route. And actually just this year, a few weeks ago, we saw a natural gas tanker make its way from Scandinavia all the way to Asia, unescorted by icebreakers, which is one of the first times that's happened. But I think the most interesting route is going to be this green route, sort of this over the top. It's in international waters, it's deep waters, you don't have to pay anybody anything to go through this. And probably in, let's say, 10 to 20 years, we'll start seeing this become commercially viable. It's not today, it's not tomorrow, but probably in a couple decades or so. And that's going to potentially change the trade routes for the world when you can get from Asia to Northern Europe by just going across the top. Okay, I'm going to skip that just in the interest of time. Let me talk about threats to infrastructure. When we think about sea level rise, a lot of people think about places like Bangladesh, like some of the Pacific Island nations, and they have very, very pressing problems. I mean, they absolutely, it's worth thinking about that. But from a security perspective, here's a few to think about. So I don't know if anybody knows what this little forlorn atoll is. If you've been out there, yes, I was out in Diego Garcia for a week one day. And it is a tiny little speck just south of the equator to the southwest of India. It's actually owned by the Brits, hence British Indian Ocean Territory. But the Brits basically let us do anything we want from a security perspective there. And I would argue that Diego Garcia, in some way, shape, or form, has been vital to just about every Department of Defense operation in Southwest Asia for the last 30 or 40 years, maybe longer there. And so we use it a lot. It's maybe 1 to 2 meters above sea level on a good day. So I've asked the people in the Department of Defense at the Assistant Secretary level, it's like, so what's the actual local rate of sea level rise at Diego Garcia? And they kind of look at their shoes and kind of shrug their shoulders. It's like, you know, don't you think it might be worth knowing that? So hopefully we'll try to get that up. So I asked Congress. Maybe if Congress asks the question, they'll get a better answer than when I ask it. Sometimes works that way. Other things, so Kwajalein, another little atoll, this one in the middle of the Pacific there. The Air Force is building something called a space fence. We need it. This is how you track everything up in space, and that's a really good thing to do for many reasons, including security. It's the Air Force though, so nothing's cheap. So each one of these radars, very capable, roughly $1 billion or so. 250-page environmental impact study. Guess what they never thought about thinking about on Kwajalein? Sea level rise. So the AP, the Associated Press, actually figured that out, and then it's like, oh, the contractor, the vendor, the sponsor, the requirements. But it's funny if it wasn't so sad. This is a $1 billion satellite or radar that's supposed to last, you know, somewhere between 20 and 40 years, or at least the basic installation. It'll be lucky if it gets to, you know, 15. And then they're going to have to rebuild it. Much more expensive because we didn't really think about that changing environment. And then this is Norfolk Naval Base. This is not last week, but this is actually in another ice storm. I think this was Irene. So the Navy basically goes and gets their ships out of port, which is what we're supposed to do because one, they're available and they're not getting beat up in the piers in 60 or 70 knot winds. But so the sailors come down, so this is great, you know, so everybody's getting ready for the hurricane, and you basically kiss your spouse goodbye and say, hey, enjoy the hurricane, I'm going out to sea. Drive your car down to the base to get on the ship, except maybe they didn't think about the storm surge. Nobody told them. So when you come back home, you find that's what your car's being through, not so good. But what's happening is, again, just as we've seen with Irma, it's taking less and less of a hurricane to produce those kinds of impacts as the sea levels rise. Okay, and then, you know, the humanitarian assistance, disaster relief, you know, this is kind of what we're seeing. You know, that's Harvey, and this is actually, that's St. Martin, actually, right now. So the DoD, as of this morning, has about nearly 12,000 soldiers, sailors, airmen, and Marines. They'll be very helpful. They can do a lot of things. But these are then missions that we're not doing on something else, and eventually it becomes a capacity issue. Okay, I'll probably finish up here. So we have Syria, and I talk about Syria because it's been in the news so much, and there is in fact a climate threat to Syria. But it's not the very simple climate change caused Syria. That is frankly not correct. It's also not correct to say that climate had nothing to do with Syria. The truth is, unfortunately, somewhere in the middle. If anybody's ever had to do, these are never any fun, but if you've ever had to do accident investigations or mishap investigations, you often find that it's a chain of events, right? No one single thing caused it, but A led to B, led to C, led to D, nothing broke that chain, and then you get a bad outcome. Really, you can trace the Syria tragedy back to the 1970s. Assad said, I'm going to go be self-sufficient in things like barley and wheat. Now, you would like to have thought his advisors would have said, hey, boss, we're like in the Eastern Mediterranean. It's kind of a dry place here. But they said, sir, you are a smart, powerful, and handsome man, and we'll get right on that. So, now, I can't imagine that ever happening in our country. But that's how that worked. And by God, they did it. By the 1990s, they were self-sufficient. But they did it by draining their aquifers, draining their rivers. A number of non-climate things happened, like the Iraq War, dumped some million refugees into the cities there. But then about a decade ago, they had a horrific drought and heat wave. From a science perspective, you can in fact attribute a good part of that intensity and severity to climate change. And now you have farmers who just have nothing. So you now dump 750,000 farmers with zero, just nothing, into the cities on top of those million Iraqi refugees. It's Assad. He's not taking care of his people. And then you can have groups like Al-Qaeda, Iraq, like ISIS, say, I will take care of you. I will give you food. I will give you shelter, security for your family if you join my group. And I would challenge anyone in here, if we were that desperate, what would we say? I don't think it's a simple answer. So I don't honestly blame the people who did that because they were desperate. But climate was one of the components that led to that. Okay, I'm going to just kind of keep on going. This is probably useful to know. And it's very good that Secretary Mattis has said that climate and climate change is one of, not the, but one of the risks that he, as the Secretary of Defense, needs to manage. So that's actually a very, very useful thing to say. If you want to read how the intelligence community thinks about this, you can actually find this. This is out on the web. It wasn't leaked. It's posted. It's unclassified. Implications for U.S. national security of anticipated climate change. Rolls right off the tongue, right? But it's written by the intelligence community. But again, career intelligence professionals, not politicians, wrote that. And that's been up there for a little while. There are lots of technical solutions that we can do. How do you put together the right teams? How do you look at this in terms of risk management? In Q&A, if you want to know what you can do as individuals, ask me why I have a llama, and I'll be happy to tell you in Q&A. Okay, energy and yeah. What's the good news? The good news is different people, messages and messengers are aligning, all the way from the Pope talking about the moral aspects, Secretary Paulson talking about big business, the security professionals are increasingly talking about this. And yes, we have the environmental groups. There's my polar bear, because you've got to have a polar bear. But different groups talking to their respective constituencies is in fact useful, and we do see the tide of public opinion moving. This is really risk management. I'll just say this is really risk management. There are some additional risks that I have not talked about out there, including geoengineering and climate intervention. We can talk about that if you would like to. I'll just leave with a couple quotes here from both Admiral Nimitz and Secretary Shultz, neither of whom I think would self-describe as tree huggers. But Admiral Nimitz, and this is after Admiral Halsey ran through a typhoon and killed 700 sailors and sunk three U.S. destroyers, it's very dangerous to be grudging in taking precautions. And Secretary Shultz said, why don't we just take Reagan's example when he was dealing with the ozone hole and take out an insurance policy? So lots of sort of big picture stuff. Let me just try to make this a little bit more personal. This is the house I lived in when I was in Mississippi working as the one-star oceanography, or basically operational weather commander, because that's where our base was. And if you ever wonder what a 9-meter storm surge does coming up your street, that's my house after Katrina. That's me. When we say we lost our house, we really did, because this is what we found coming back. So it's either all the way that way in the railway tracks, or it's that way in the Gulf of Mexico. We think it's that way, but we're not sure. I don't put this up for sympathy. We were, again, maybe some of the luckiest people on the Mississippi coast for a variety of reasons. But think about the hundreds of thousands and millions of people who go through this and they have nothing. Think about what happens with Syria when you have desperate people combined with poor governance and governments who do not take care of their citizens and the population. And then we can get some very bad outcomes. And the United States security enterprise and the military oftentimes then get involved. And they can be triggered by events like this. So Winston Churchill is alleged to have said, turns out he never said anything, but he's alleged to have said that Americans can always be counted upon to do the right thing after trying every other possibility. So maybe we're still trying those, but we'll see. We'll see if we're going to do that. I kind of like to think more, though, about, especially about Apollo 13, because when we are focused, so here's my belief, when we are focused, we still are the exceptional country. And we do amazing things, and we can do incredible things. I mean, the more I read, as you know, through history of Apollo 13, there is no way those astronauts should have come back alive. Absolutely no way. But we did not let ourselves fail. We harnessed overnight the expertise, the engineering, the scientific, the creative expertise of our country, and we solved a problem that we really shouldn't have been able to solve. Climate change is easy compared to that. It's big. I don't make any regards for that, but we have more time than NASA had to fix Apollo 13. When we get focused, we'll be able to do this. So that's, I'll leave you with that, and happy to take any questions. Thank you very much. Sure. However we'd like to do this.
Sounds good. Oh, thank you very much. Very good. We have a number of great questions, particularly from our students rather. There's some of them, we have so many, and we have a little bit of time. I'm going to kind of overlap some of them.
Okay, sure.
There's how relative are the scales you were showing? Could the Earth be in a cycle? Is the Earth just going through one of its phases?
Okay, so that's a really good question, and fortunately we have quite a number of scientists who look at what we call paleoclimate, and this is really digging back from the time before we had thermometers, because we've only had thermometers for maybe 250, maybe the earliest ones about 300 years ago. So obviously the Earth's been around a whole lot longer than that. But you can use things like looking at corals, you can look at pollen, you can look at what kind of insects lived in different places. And you can start reconstructing temperature. And what we see is that since we came out of the Ice Age, roughly 8,000 to 10,000 years ago, the Earth is basically being plus or minus about 1 degree Celsius. So let's say 1.5 degrees Fahrenheit. And there can be little pieces of, whether it's the sun, dimming a little bit. Right now the sun is actually dimming, but we're warming. If you get big volcanoes, they tend to block out sunlight for a couple of years. So we can pretty much explain sort of the dips and the wiggles in there, because at the end of the day it's pretty simple. It's like energy comes in, energy goes out, and you got to be able to balance those. And how much of that energy do you hold? And that's actually what the greenhouse gases do. So again, we go back to that theory of 170 years ago. We know that the greenhouse gases act like a blanket. Turns out if we did not have any greenhouse gases, you guys know how cold the Earth would be? It'd be like 50 degrees colder Fahrenheit than we are today. We'd be an ice ball. So it's really good that we have greenhouse gases. But we're like Goldilocks. We don't want too little, we don't want too much. We've had about the right amount for human civilization, and now we're putting a ton more in, and we're seeing the impact. So we're pretty sure, yes, there are still natural variations, but now it's like this. The natural variations are being superimposed on a big upward cycle. Thanks.
Great. What about plant and animal species that are beneficial to humanity? Are they threatened by climate change? To what extent?
Yeah, it's another great question, and there's a lot of people looking at agriculture and climate. The general consensus, and I use that term with a little bit of caution, is that we are pretty close to reaching some tipping points for some pretty important grains, like wheat, like soybeans. It looks in general that the water, when plants, and I'm not sure who here works in agriculture, because you probably know a whole lot more about this than I do, but I've worked with some soybean and some other folks. You know, so when the rains come and how much comes during critical times is really, really important. I showed on those climate models, they're really good for averages. They're not so good for getting specific ups and downs. So take this with caution, but in general, it looks like we are getting close to some tipping points if we just sort of kept the agriculture and where we kept the agriculture. So the ways that we can look at that is improve farming techniques, continually improve farming techniques, and also the genetic engineers. How do you genetically modify these crops to be more drought tolerant, to be more heat resistant? And it's kind of a race, right, between the warming world and changing rainfall patterns and the really smart scientist, agricultural scientist. And it's not clear to me which side is going to win. So I don't want to be like totally gloom and doom and, oh my God, we're all going to, you know, we'll never have another buffet again. But this is, you know, if we stop meeting the world's food needs, that becomes a real issue.
Another good one, I think. How do you feel about the Paris Climate Change Agreement?
Paris, that almost always comes up now. Paris to me is the ultimate Rorschach test. So you guys all know what a Rorschach diagram is? It's one of these in which you either see the beautiful vase and the lady or the witch, right? You know, and you make your eyes, it's the exact same thing, and you can make your eyes see something really beautiful or really ugly. And Paris to me is like that. Why do I say that? Because simultaneously, you know, you could argue that Paris was the first time that the world really came together and we really were going to start coming together and says, yes, we need to tackle greenhouse gases. It was everybody bring what you can, and we'll start working this. And I think the proponents of Paris said, you know, we understand Paris by itself is not going to solve climate, but it's on the right road, and that's very, very important. That's the good side. The other side of Paris is it's non-binding, and if this is the biggest problem that the world is facing collectively in the 21st century, how do you do that with a non-binding treaty? Whatever you bring for your contribution to reducing your greenhouse gases in some way, shape, or form, can be whatever you want. It's not really even verified. And even if everybody does what they said they were going to do, we're still going to have about 3 degrees Celsius, or about 5.5 degrees of Fahrenheit, of warming by the year 2100. And the Accord says we really want to stay at 2. And it'd be even better if we could stay at 1.5. Yet the Accord has 3. So you can, at the same time, you can say this is a wonderful road because we finally got agreement. You can also say, yeah, but it's worthless. So that's the paradox of Paris. So obviously the U.S., the Trump administration pulled out. The part that doesn't bother me as much, there are a lot of bad things about it, but my guess is we'll probably still basically meet most of, if not all of, our greenhouse gas commitment. And that's because of economics. It's not because of politics or because people are all of a sudden woke up and cared about the environment. Natural gas is by and large cheaper now to run a power plant than coal. It produces roughly half the greenhouse gases per unit power, and that's where most of the reductions have come from. It will be interesting as we go forward to see as cities and states say, hey, we're going to be more aggressive at trying to reduce our greenhouse gases. We'll see how that plays out. My guess is if we could fast forward to 2025, 2030, my guess is we're going to be pretty much what the US said, but we may have done it in a different way than was envisioned by the previous administration.
I think we got another great question here. As an educator, have you found a way to teach someone who is profiting by not learning or being paid not to learn about climate change? The climate deniers, how do you talk to them?
Yeah, so, I mean, and it's a great question. And, you know, and it's really easy to either make fun of people or to just say, well, geez, you know, you guys just don't get it. I think the former president called them flat earthers or something like that. You know, and people in sort of your tribe, your ideological tribe, is like, oh yeah, you know, this is really good. That will not solve problems, in my view. There are different ways to come about this. So it turns out that maybe some folks who really, frankly, aren't all that excited about climate per se, but they like the idea, almost more of a libertarian idea of, hey, if I want to generate energy, you know, why should I have to pay a power company for that? Why can't I generate wind energy on my, you know, 500-acre ranch? Why can't I have solar and I should be able to buy or sell solar? So there are different ways of addressing this, and you don't always have to say, well, 97% of the climate scientists agree on this, so therefore you should do that. That's usually, again, it makes people feel good on some sides of the issue. It probably isn't a way to get people to change. So find things you can agree on. Find things that you can talk to about this. So we have, you know, a lot of now 3- and 4-star generals who are not, you know, I would say rabid environmentalists, but they are interested in making sure that our armed forces have what they need and have every opportunity to be successful doing whatever the nation requires in the future. So they understand that if Norfolk Naval Base has tremendous amounts of flooding, or if some of our national test ranges out west run out of water or have massive fires, that is not conducive to the DoD. Things like Syria draw our military into conflicts that we really had no interest in being in. That's not healthy for the Department of Defense. So you can sometimes talk about things like security rather than, oh, I need to go save the polar bears. So it's a lot of it can be framing. Not everybody will be on board, but not everybody's on board any issue.
Time-wise, I think we're going to have to make this last question, so I apologize for people who have some great questions here, but this is one that strikes me of particular interest. What impacts is climate change likely to have on Russia and China? What are they doing? Are they treating it differently than we are?
So Russia could be the big winner, except Russians are Russians, so my guess is they'll screw it up. Because you look at so a number of things are going to happen. The Northern Sea route is going to become ice-free more and more. That's a tremendous trade route, not only between Europe and Asia, but just along Russia itself, along the coast of Russia. It's much, much easier, much cheaper, much more efficient if you could reliably ship by sea rather than, I mean, there are very few roads out there. Air is very, very expensive, of course. So if that becomes reliable. Russia is really the one true Arctic nation. I mean, my apologies if there are any Canadians here. The Canadians have I was just in Canada yesterday. The Canadians have the ethos of being in the Arctic. I've seen more of the Arctic than most Canadians have. The Canadian Arctic I've seen. But the Russians have about 21% and roughly 21% of their population, about 20% of their GDP comes from north of the Arctic Circle. The US is about 0.1% of our GDP comes from north of the Arctic Circle there. So the Russians really do think about this, but they're Russian. So their bureaucracy gets in the way. They have incredibly smart scientists, theoretical scientists, but then their system ends up, you know, screwing up buildings. I mean, they know how to build in permafrost, but then if you have a lot of corruption, you cut corners, and that's why, you know, you see these famous pictures of these crazy buildings. They look like they're Picasso buildings or something, falling because of the melting permafrost. They know how to build correctly in melting permafrost, but it's, you know, you're on the take, so you do other things. So we'll see what happens. China's very worried. Near term, China's issue is not so much climate change, but their issue is simply pollution. Anybody been to China? Probably a bunch, right? Can you see? I mean, you can't see from here to the end of the room half the time. It's just crud in the air. And the government realizes the population's getting very unhappy about that. And in China, they have, you know, the mandate from heaven, right? You lose the mandate from heaven, the government gets thrown out, you get a new government. That's how it's worked for, you know, about 4,000 years there. So that's why the government's interested in cleaning this out, because they want to stay in power. Longer term, I think at a technical level, they realize they do have some real issues. We talk about Norfolk and New Orleans and Tampa on the coast. They have Shanghai. They have a number of cities that probably none of us even think about that are 2, 3, 4, 5 million people on the coast. And the East China Sea is just as vulnerable to sea level rise as the Atlantic Ocean. And I think they realize they've got that issue. They've also got in some of their agricultural belts will probably not only heat up but dry out. And they've got a real issue there. So China has real climate issues. I think the government knows it. I'm not sure they have quite figured out all the things they're going to do. Thank you.
Thank you very much.
Thank you, Dave.
Thank you very
Thanks
much.
so much.
Don't forget Dr. Titley will be at all right at 6.
Thanks.
Don't get up and leave yet. couple of quick announcements. Upcoming programs. Fantastic program on the